Good day everyone! Today we will demonstrate an activity about substitutes and adulterants of cannabis sativa. So here it is now. We have here the substitute of cannabis sativa. We have here the first one, cassava leaf, papaya leaf, bitter gourd leaf, neem leaf, and the lady's finger leaf. These are the 5 common substitutes for cannabis. So now, I'll be introducing you the equipment and apparatus we will use for this activity. The first one here is we have our basket, the chopping board, the glass, the forceps, the cutter, pin, and then the measuring tape and ruler, the dropper, yarn, and petri dish. And before I forgot, this is our saline solution and diluted HCl. And before I forgot, I will introduce you our one equipment here that we will use, which is the microscope. And here are all the things that we will be using for our activity.
The lady's finger leaf measures 2.5 inches in both length and width, showing a nearly square shape. The neem leaf has a width of 2.4 inches and a length of 3.7 inches, making it slightly elongated. The bitter gourd leaf measures 4.5 inches in width and 3.7 inches in length, giving it a broad and wide appearance. The cassava leaf is the largest in width, measuring 5.4 inches with a length of 3.5 inches. Lastly, the papaya leaf has a width of 2.10 inches and a length of 3.7 inches, showing a moderate size compared to the other leaves. In this activity, we examine different plant leaves and describe their leaf type, venation, and margin. The leaves we analyzed were bitter gourd, papaya, neem, lady's finger, and cassava. Bitter gourd leaf, or known as Mumridica charantia. The bitter gourd leaf is a simple leaf, meaning it has one undivided leaf blade attached to the petiole. Its venation is palmate, where the veins spread outward from the central point of the leaf. The margin is lobed, forming several rounded divisions around the leaf edge. Papaya leaf, or known as Carica papaya, is also classified as a simple leaf, even though it appears deeply divided. The venation is palmate, with large veins radiating from the center. Its margin is deeply lobed, which gives the leaf its large star-like appearance. Neem leaf, or known as the Azadirachta indica, are pinnately compound, meaning the leaf is divided into several smaller leaflets arranged along a central rachis. The venation is pinnate, where smaller veins branch out from the midrib. The margin is serrated, which looks like small, saw-like teeth along the edge. Lady's finger leaf, or the okra, is known as the Abelmoschus esculentus. The lady's finger leaf is a simple leaf. It has palmate venation, where several veins extend from the base of the leaf. The margin is lobed, forming multiple pointed sections around the leaf blade. Cassava leaf, or known as the Manihoti esculenta, appears divided into several narrow segments and is often mistaken for a compound leaf. However, botanically, it is considered a simple leaf with palmate lobes. Its venation is palmate and the margin is smooth or entire rather than serrated. After observing their characteristics, we determined which leaf sample does not completely match the identifiable features. So here's the reason for eliminating cassava leaf. Cassava leaf was eliminated because one of the important anatomical parts required for identification is the dorsal surface of the leaf. That was not clearly observed or identified in the sample. Since the activity requires complete identification of leaf structures such as apex, midrib, veins, margin, ventral surface, and dorsal surface, the absence of this identifiable part means the cassava leaf does not meet the criteria for full analysis. So therefore, it was removed from the list of valid specimens. In the next part of the activity, we prepared a saline solution and diluted HCl. These solutions were used because the remaining 4 leaf samples would be observed under the compound microscope. In the natural preparation, the bitter gourd leaf displayed its epidermal surface in vein structures. but no noticeable trichomes were present. With the addition of saline solution, the cells appeared more distinct and clearer, allowing better observation of the epidermal pattern. However, trichomes were still not visible. When diluted HCl was added, the structures of the surface became more emphasized, but the observation continued to show mainly the epidermal layer without trichomes. In its natural or pure preparation without any liquid, the papaya leaf showed its epidermal surface, where the outer layer of cells could be observed. However, no visible trichomes were observed on the surface. When saline solution was added, the cells became clearer and more hydrated, making the epidermal layer easier to see under the microscope. Despite the improved visibility, trichomes were still not observed. When diluted HCl was applied, the leaf surface structures became slightly more defined, but the observation still mainly showed the epidermal layer without trichomes. Under the natural or pure preparation, the neem leaf showed its outer epidermal layer, where the surface cells could be seen under the microscope. In this observation, no trichomes were detected. When saline solution was added, the hydration of the sample improved the clarity of the epidermal cells, making them easier to observe. However, trichomes were still not present. With the addition of diluted HCl, the leaf structures were slightly enhanced, but the observation continued to show epidermal characteristics without trichomes. In the natural preparation, the lady's finger leaf clearly showed trichomes, which appeared as small hair-like structures on the leaf surface. These cystolithic trichomes were visible along the epidermal layer. When saline solution was added, the leaf cells became more hydrated and clearer, and the trichomes remained visible, confirming their presence on the surface of the leaf. When diluted HCl was applied, the structures became slightly more pronounced under the microscope. The cystolithic trichomes on the lady's finger leaf were still observable, making it the only sample among the 4 leaves that clearly showed this feature. In addition to the identified leaf sample, there is also an unknown leaf sample which is presented as a dry specimen. This sample was provided as an example for observation in comparison with the other leaves. Pure preparation. In its natural state without any liquid, the surface of the leaf showed its epidermal layer and several hair-like structures. These structures are identified as trichomes, which appear as small projections extending from the leaf surface. Even though the sample is dry, the trichomes were clearly visible under the microscope. With saline solution, when a drop of saline solution was added to the slide, the leaf sample became slightly rehydrated, which improved the clarity of the epidermal cells. Under this preparation, the trichomes were still visible, and their shape and distribution on the leaf surface became easier to observe. When it comes to the diluted hydraulic acid or the HCl was applied, the surface structures became more defined under the microscope. During this observation, the trichomes remained visible, confirming their presence on the leaf surface of the unknown specimen.